Hello and welcome. I'm here to showcase and explain my little Java applet that I wrote for Mr. LB. What it does is it takes, you put in some names. I'm just going to use numbers for my names. 2, 11, 12, 40, 3, 1. And then you go and put in there values. Pretty much you're supposed to take around 5 names. The original intent was 5 names. I made it variable. And then you put in their ages, and it sorts them by their age. And then if two people have the same age, it puts them in alphabetical order. So right here, I went ahead and gave 1 and 3 the same number, and as you can see, O comes before T, and so they're in alphabetical order, and they are all in, other than that, well, yeah, they're all in order according to the quote-unquote age. It's pretty quick, it's pretty simple. It was a lot of fun doing this. I didn't know any Java at all before I did this, so. Alright. I went ahead and finished this on 26th of August, which was yesterday. First of all, I went ahead and imported these two things because yeah. You know what? Let me go and I just want to go ahead and do that before I forget. Compile that sucker. Alright, so what we went ahead and did first is what we do is we call up the names, we input the names. Which is right here. Call names. What it does is we have to go and do the scanner input, and then we go ahead and ask it, hey, what's the names? You go put them all in one line into raw string, and then we take raw string and we split it at the commas and put it into names, names, and then for each entry I'm going to go ahead and take out a name, put it into here, and then I'm going to trim off all of the spaces, extra spaces on it, and then I'm going to store it back into names, and then I go and output it for display purposes. Next, what we do is I count how many names there are and store that as count. And I go ahead and I grab the ages and I carry over count into there. Here we go, call ages. It's pretty much the same thing. It's the time it goes and asks you, hey, put in however many count ages of the people. And you separate them by spaces this time. So it'll go and you input them here into this raw string, and then it splits the raw string up the spaces, puts it into raw ages, but it's in string format and we want it to be in integers. I go ahead and create my integer list right here, ages, and then for each entry I go ahead and I call out, I select one of the ages, and then I go and turn it into an integer and put it into the ages list. Then I output them for display, and we keep on trucking. Alright, so after we call the ages, I'm going to go ahead and set up 2 new arrays, 2 lists. Can I use lists and arrays interchangeably? I don't know. I'm new to Java. I haven't done anything before I started this project. Yeah, so new names and new ages are my 2 new lists, integer and string. There I have the length of count. Then I go ahead and make up, I also declare the string name, integer age, and integer x. X will be my placeholder of where to store while I'm sorting, because I have to place them somewhere. X will take care of that. And age and name are my present selectors, you'll see. And now we go ahead and begin sorting names into opposite alphabetical order. I'll explain why later, but for right now. Now what it does is we pull a name out of the hat right here, as well as the corresponding age for it, and we're not ready to place yet, so we go ahead and reset our placeholder x, or making it 0. Now, for each entry in our array, we're going to compare our selected name, even against itself. And so what we're doing, we're comparing them alphabetically, and if it's supposed to go before it in the alphabet, or is itself, we take x and add 1. So for example, x is always going to be at least 1. It's always going to add 1 because it's always going to be compared against itself. So x is going to be always at least 1. And I'll explain later on why this works if it's not clear. But this, I realized, just so happens to give you your location by comparing to everything equal or less than it. It gives the location where you're supposed to place the item. So that's pretty cool. And so then we go ahead and subtract 1 because 1 is always our default, but when you're storing into an array, 0 is the first section, so subtracting 1 is okay, because we're storing it right here as just x. And then if there's a repeat, so if 2 people were named Alfred, I can't store it into Alfred, into the same section twice, so if there's already a name there, it's going to go and take x and subtract it by 1, and go and put it in the one before it. I'll explain that more as well in a moment. After we're done getting our value of x, we go ahead and just store them right into our new names and new age list, the corresponding age and name, so we always keep them matched up. Keep in mind these are blank, so it's nice. We're just putting them into the slots where they will be later. So after we're done sorting out the names into our reverse alphabetical order, we go ahead and reset the new names and new ages so that they will be new again, and we put them back into names and ages, which are our defaults to pull from. So for each entry, I go ahead and I take names and I override it with the new names. Since everything is in new names now, it's okay to overwrite names. And then I fill new names with a null value like it was before. Same concept for ages. I put every entry of new age into ages, and then I fill new age with 0. Now I begin sorting the ages. For each entry, we pull an age out of the hat, as we did with the names, and we reset x, our placeholder, where we're going to store it. Now, for each entry, we are going to compare said pulled age to the rest of the numbers. Oops. And now, for this, if our number is greater than or equal to a number, it's going to add 1 to x. It's going to count how many is higher. And I'm going to show you right now why we do that. Let's say we have a list of numbers here: 36, 72, 72, 45, 18. Alright. Now, our counting, what I had realized was, I had made a thing of, if any number was greater than or equal to a different number, it overrid it, and this is what I found out. For if we do 36, there's 2 36s there. If I do 72, oh wait, yeah, equal to or greater than. So 72 is going to override that, override that, override that, override that. It's going to override everything. 45, yeah, it overrides that one. I'm getting quite tired. And for 18, now, if you notice there's one 18 here, so let's go ahead and put 18 there. There are 2 36s here, so let's put 36 in the second slot. There are 3 45s, so we'll put 45 into the fourth slot. 72, there are 5 of them, so I'll go ahead and put 72 in the fifth slot. And then now if I were going down this list here, we would have put 72 in the fifth slot immediately, in the second, as the second thing. And then we would have tried to do it again, but it's full, and so we'll go -1 and put it into the fourth slot. And then if you notice, we have our numerical order. It was actually pretty simple, so that's pretty neat. So yes, so we automatically, first, after we get our placement, as you just saw, we're going to take x and subtract it as 1. If you recall from before, it's because that way our our 36, which is a value of 1, will be stored into slot 0, which is the first slot. But then after that, as you saw with the 72, if there are any repeats, so if our little fake list down here, which was all zeros before we put it in, if the number isn't 0, so if it already says 72, it's going to subtract x one more time so that it gets put into the slot before it, the blank one. And the reason why we went ahead and did our reverse alphabetical order first is because if these above names were associated with words, Z, Y, X, W, T, it goes down this list, so it would put Z in first. Let's go ahead and just put a bunch of spaces in here and hit insert. No. Where's insert on my keyboard? Oh my goodness. Here we go. Is that the button? There it is. Alright. So 36 we would have put in Z first, and our second one we would put in a Y. And then when we try to put X in, we can't, so it's going to go to the one before it. And that's the secret right there. And then we go ahead and put in our other ones. But as you can see, the Y got put in first. The very last, being how the heavier letters, the later letters are first, it gets put into the end first. I noticed since it always gets put into the end first, that's why I pretty much put them in reverse alphabetical order, so that the Z's and X's and such would be placed first, and anything under it, our A, B's, and C's, will get placed next, which will be before it in the list. So pretty much, I noticed that it always goes to the back, so I might as well flip it. It's late, I don't know if I'm explaining that well. Ask questions in the comments if that didn't make sense. And then we go ahead and store them into our new age and new name. And then we simply go and print the results. I go ahead and I'll put a lot of spaces just to get away from the rest of the data for aesthetic purposes. And then for each entry, I go and display name : age, just so you have a look-see, have them compared to each other. And if you notice, you'll see the unalphabetical order there. And then I go and show you the new list of names and ages in the correct new sorted order. So we have our names of Joseph, Caroline, Max, YouTube as 2 words, MeTube, and toothpaste tube. Alright, Joseph is 16-year-old, Caroline is a 17-year-old, Max, I'm 24, YouTube is, how old YouTube? Like, I don't know, I'll put 10 years, why not? MeTube, I haven't really been doing YouTube videos that long, and toothpaste tubes have been around for like 40 years. 410 years works as well. Typos, why not? Hit enter. As you see there in reverse alphabetical order, Y comes after T, comes after M, E comes after MA, comes after J, comes after C. And then we get our order of the ages, so MeTube comes first. Oh no, I did that wrong. I was supposed to go and show some twins in there. Let me redo this real quick. Alright, so names separated by commas. Max, Jack, Caroline, dog. Alright, so Max and Jack are both going to be 24. Caroline, this time it's a different Caroline. She is 29, and the dog is 7. Alright, as you can see, M comes after J, comes after D, comes after C. But in alphabetical, in this order here, we have the dog is the youngest, 7, and then Jack and Max, but they're in alphabetical order, and that's because it takes, see, 24 is greater than or equal to 3 of these, so it's going to go and put the very first one, which is Max, into slot number 3. And then when that's full and they try to do Jack, they can't, so they put it into number 2. And that's why if it's in this order, it'll always be in alphabetical order, because the ones supposed to go after are first. And then the next age, Caroline, is greater than all of them, it gets put in the fourth slot. So that's it. It's pretty simple stuff. I had a lot of fun doing this project. Coding these puzzles are so cool. I'm looking forward to trying to find more of these. I'm going to pressure Mr. LB into letting me know his next assignment so I can have fun doing them on the side. It's just so much fun. Thank you for watching. I hope you have a wonderful night, day, life. Comment and say hello, I'm lonely.